Here we have the infinite series of cosine of n pi, and we want to show that this series diverges. And so let a sub n be cosine of n pi. And then we can see that when n is 1, then we get cosine of 1 pi, which is cosine of pi, and cosine of pi is -1. When n is 2, then we get cosine of 2 pi, and cosine of 2 pi is 1. And then when n is 3, then we get cosine of 3 pi, and cosine of 3 pi is -1. And then when n is 4, then we back at 1. And then when it's 5, then we add -1. And then when n is 6, then we add 1. So what we're seeing the pattern here is that the cosine of n pi is equal to -1 if n is odd, and then cosine of n pi is equal to 1 if n is even. And therefore the limit of a sub n does not exist. And therefore, by the end term test for convergence, this series right here diverges. So we have shown that the limit of a sub n is not equal to 0, and therefore we can say that the series cosine of n pi diverges.